Hey class, we spent last class period working on 7.5 and it was the introduction to the graphs of parabolas. And we used the equation y minus k equals a parentheses x minus h squared. This is the standard equation for a parabola. Now, I talked about how we're going to go further in depth in chapter 9 when we really talk about parabolas. But just to review from chapter 7.5, we talked about how the vertex given this equation is h comma k. And remember, the vertex is kind of the corner or the starting point where the graph kind of takes its shape. The other thing that we talked about was the orientation. And the orientation was the letter A. If you see it at the very beginning of the equation, A tells us which way the parabola opens, either up or down, and the shape of it, which means basically whether it's skinny, if A is greater than 1 or less than -1, or if it's fat, if it's a fraction in between -1 and 1. Okay, today we're going to get a little bit more complicated. We're going to talk about 7.6 quadratic functions. A quadratic function is a function that can be written in either of two forms. Now you're going to recognize this first equation because it's exactly what we talked about in 7.5. The only difference is instead of y, we use f of x. Now don't be alarmed. I know you guys aren't fans of f of x, but it's not a big deal. Anytime you see g of x or f of x or p of x or any form like that, just replace f of x with y. Now, in the previous equation, it was y minus k equals a parentheses x minus h squared, which almost looks exactly like the one we have on this slide. However, here's the only difference. Had we subtracted that k to the other side, now we have exactly what we had written in the previous one. Okay, so this is the one equation that we've seen so far. However, being great math students that you guys are, we have to be prepared for us not getting that cookie cutter sweet equation. And so we're going to have this general form of f of x equals ax squared plus bx plus c. Now, some of you sharp individuals may recognize this equation as the equation of a quadratic equation, right? And this is how we would solve quadratic formula, completing the square, factoring. This is the quadratic equation. Instead of y, though, it says f of x. So it says f of x equals ax squared plus bx plus c. So we're going to practice graphing both in the completed square form that we did in 7.5, and we're going to work on with the general form ax squared plus bx plus c. So I'll start you off with an easy one. This one looks really, really similar to what we did in 7.5. The only difference is that f of x we changed to y now. So we have y equals 6 minus 1/2 parentheses x plus 4 squared. This almost looks exactly like we had it in 7.5. The only difference is, let's subtract that 6 over just to make you guys nice and comfortable. Now we know how to graph this. So here is our equation. Y minus 6 equals -1/2 parentheses x plus 4 squared. Now, if you remember from 7.5, we know how to find the vertex. The vertex, remember from the first slide of this lesson, it's h comma k. And h refers to the number that's being subtracted with x, and k refers to the number that's being subtracted with y. But just remember, subtraction is a good thing. So it's always the opposite of that. So in this particular problem, since it's x plus 4, we actually remember that as -4. And when it's y minus 6, that's actually positive 6. So we're going to plot the point -4, comma 6. -4 to the left, up 6, and there is our vertex. Okay, now we have to look at that orientation, or that letter A. That letter A is the number that's being multiplied with that x squared term. Now if we look and we recognize that the orientation is negative, because it's negative, that means it's going to open down. Because A is negative, it's going to open down. Now that number in front is -1/2, which means it's going to open down, but it's also a fraction, which means it's going to be a little bit on the fatter side. So we're going to sketch our graph, make it a little bit wider than maybe a normal graph, and we've sketched our parabola. So now we're going to look at the next example. Now it's a little bit different, right? We're not given that completed the square form. We're not given that beautiful equation from 7.5. Now we're going to have to do a little bit of work ourselves. So what we're going to do is, first of all, we're going to replace g of x with y. So we get y equals x squared plus 4x plus 1. Now, we have to have, somehow we have to have x plus or x minus something squared with the y and a number on the left-hand side. So somehow we're going to have to do this to where x's are in parentheses and they're being squared. So the number one thing that we're going to have to do is maybe we're going to subtract that 1, and that way we can deal with things that have something in common on that right-hand side. So we have x squared plus 4x. Okay, now we're going to have to flash back to chapter 7, but 7.1 or 7.2 that we talked about last semester, and everybody's favorite thing, completing the square. So basically what we need to do is we need to make sure that we have x plus something over here on this right-hand side. Now the only question is, okay, well, as it is right now, all we have is a GCF on that right-hand side. We're not going to be able to multiply by something. So what we have to do is we need to complete the square. Now we're going to have to complete the square, so we need to figure out what we need to add. Now, I've already told you a great joke, and I've already had an A and B conversation, and I seed my way out of it. So if you remember, what we need to do is we need to add b over 2 squared to both sides. We need to add b over 2 squared to both sides. So if I'm looking, a is 1, b is 4. So what I need to do to both sides, I need to add 4 over 2 squared, but to both sides. So what we're going to have on the left-hand side is we're going to have y minus 1 plus 4 divided by 2 is 2 squared. So that's going to be 4 equals x squared plus 4x plus 4. Now this is going to make it way easier. So now I have y minus 1 plus 4. Well, negative 1 plus 4 is positive 3. On the right-hand side, if I need to x method, no big deal, I can do that. If I have x squared plus 4x plus 4, what multiplies to 4 and adds to 4? It's the same exact thing. Plus 2 plus 2. But instead of writing it twice, I'm going to save myself some ink and have this. And now, if you look at this equation, it looks just like the equation that we had on 7.5, where the vertex is negative 2, comma, negative 3. Now, the only tricky part is, what's the orientation? What's the a value? Well, the number that's in front of x plus 2 squared is 1. So a is 1. So if it's positive, that means it's opening up. So I go to left 2 and down 3 because that's my vertex, that's my corner. That's where the parabola starts. And since it's positive, the orientation is positive, that means I'm going to be opening up, but it's not going to be skinny or fat because 1 is just like the normal parabola shape. It's not going to be skinny, it's not going to be fat. So I'm going to draw our parabola this way, and you've graphed this equation. Okay, now I understand that this is going to be a very long process if we have to do this every single time, instead of just having the equation where it's perfectly set up for us, like on number 6. We might get problems like this, where it says x squared plus 4x plus 1, and it's going to be a long process to complete the square every single time. Lucky for you, I'm nice, and I'm going to give you guys a shortcut. Okay, here's what we need to do. If you look in the book on 7.6, 7.6 is going to give you this crazy equation where you're supposed to have this whole equation memorized. And you would end up getting y minus parentheses, the opposite of b squared minus 4ac all over 4a equals a parentheses x minus opposite of b over 2a squared. Obviously, you're all going to remember that, so you're all going to remember that the vertex is naturally the form opposite of b over 2a, comma, negative b squared minus 4ac over 4a. I'm not going to remember that. You're not going to remember that. So here's the easy way to remember it. Instead of memorizing all of that stuff, we're going to remember this equation. We're going to remember that x equals the opposite of b over 2a. Now, in chapter 9, we're going to talk more about the axis of symmetry. The axis of symmetry is just what it sounds like. The axis means a line. Axis just means a line, just like the y-axis or the x-axis. Those are lines on the coordinate plane. The axis of symmetry. Symmetry, if you remember from geometry, something that is symmetrical means it's the same on both sides. So it's the line of, basically it kind of serves as a mirror. If we were to cut the graph in half, we would see the same exact thing on the right-hand side and the left-hand side of that graph. So we're going to remember this equation for the axis of symmetry. X equals the opposite of b over 2a. Now, where am I going to get this b and the a from? Well, if you remember, y equals ax squared plus bx plus c. Just like the quadratic equation, if we were doing the quadratic formula, or if we were doing completing the square, we would need to know what a, b, and c was. So x equaling opposite of b over 2a is going to be an easy thing for us to solve. So for example, in our last problem, we had x squared plus 4x plus 1. So we had y equals x squared plus 4x plus 1. So what we do is we take this formula, x equals the opposite of b over 2a. Well, what's x going to equal then? X is equal to, well, the opposite of b is going to be negative 4. So we're going to have negative of negative 4 all over 2a. Well, 2 times a is just going to be 2. So we have x equals negative 4 is positive 4 over 2 equals 2. So x is going to equal 2. That's our axis of symmetry. That's the line of the mirror where the graph is going to be the same exact thing on the right-hand side as it is on the left-hand side. Now, instead of memorizing all of this stuff like the book wants you to, okay, I'm going to give you a shortcut because I'm nice. Okay, so here's what we do. When we have this problem, y equals x squared plus 4x plus 1, we've already solved for what the axis of symmetry is going to be, x equals 2. That's a vertical line at x equals 2. But we're trying to find the vertex, the point for the vertex. How am I supposed to find the y value if I only know the x value? Well, if you look at this equation here, what do you think I could do with that x equals 2? I could plug it in. Well, if I have y is equal to 2 squared plus 4 times 2 plus 1, I end up getting y is equal to 4 plus 8 plus 1. And I end up getting y is equal to 13. So here we have the problem where a is 1, b is 4, and c is 1. So when I'm solving for x equals the opposite of b over 2a, I take the opposite of b, and I put it over 2 times the a value, which will give me negative 4 over 2, which equals negative 2. So I know that my axis of symmetry is the vertical line at x equals negative 2. Now the question is, okay, well that's great, but I'm looking for my vertex. And my vertex is a point, which means I need an x value and I need a y value. Well, how can I find a y value if I only know the x value? I know that x equals negative 2, but how am I supposed to find the y value? I could plug in negative 2 in for x. So negative 2 squared plus 4 times negative 2 plus 1. Y equals 4 minus 8 plus 1. So I end up getting y equals negative 3. Now, y equals negative 3 is great, but I needed to write it as an ordered pair. Negative 2 comma negative 3 is my vertex for this line. Now, what many of you with great memories will realize, hey, that's the same exact vertex that I got over here on the previous problem. But notice, on this slide, I did not do completing the square. I did not spend any time making a funny joke and A and B conversations to see your way out of it. No, instead, I went straight to this formula where it's x equals the opposite of b over 2a. And instead, now I just plug in these values. I found the x value for my axis of symmetry. plugged it into the y value, and I got my vertex. Now it's going to be really easy to graph this parabola without completing the square because I know that the vertex is at -2, -3. Now, my a value when it comes to parabolas will tell us the orientation. Does it open up or down? Is it skinny or fat? Now, the beautiful part of this is the a value that comes in the parabola is the same exact a value that comes in the equation. That same exact 1 that comes before the x squared is still going to be my orientation. So it's going to open up, and it's going to be neither skinny nor fat. And I just graphed the parabola in much faster time than I did when I completed the square. So that's the beautiful thing about this shortcut. Now, remember, we're not going to do what the book told us to do, where we're going to memorize all of this stuff. Instead, all we need to do is remember this equation. So here is our third example. F of x equals 6 minus 6x minus x squared. Now, I'm going to rewrite this if that's all right with you. What does f of x equal? That's right, we can replace that with y, and I'm going to rewrite this in the order that makes sense to me. Sorry, plus 6. Sorry, I'm bad at math. All right, so here's what we need to do. Instead of completing the square, A and B conversation, see your way out of it, add b over 2 squared to both sides, factor, square root, solve. Instead of all of that stuff, here's what we're going to do. We need to remember the axis of symmetry is in the equation of x equals opposite of b over 2a. So x is going to equal the opposite of b, so that's going to be positive 6, all over 2 times -1, the number in front of x squared. So I end up getting -3 as my answer. X equals the -3 is the axis of symmetry. So if you really wanted to, what we could do is we could say, all right, the axis of symmetry is x equals -3. So what that means is the vertical line at x equals -3 is going to be my line of mirror. Remember, we're going to cover this more in chapter 9. I wouldn't be too concerned with it, but it's a good thing to know. So x equals -3 is the vertical line at x equals -3. That's going to be the line of mirror, the axis of symmetry that cuts our graph in half. But let's find our y value because we need to find our vertex first. So y is equal to -x squared minus 6x plus 6. Now, what should I do with that -3 again? That's right, I should plug it in for the x value. Y equals negative. Remember, PEMDAS tells me to do exponent first, not multiplication. Minus 6 times -3 plus 6. So I end up getting, using some sweet math skills, I end up getting y is equal to 9 plus 6, or 15. So I end up getting -3, comma, 15. Oof, that's going to be tough to handle on my graph, but let's assume that -3, comma, 15 is right about here. Okay, now, the orientation, what's the a value? What's the number in front of x squared being multiplied with x squared? That's going to be -1, which means it's going to be up or down. It's going to be down, that's right. So it's not going to be skinny or fat because it's a 1, but it is going to open down. So it's going to look like this. All right, perfect. We just graphed 3 different parabolas. One was in the form of y minus k is equal to a parentheses x minus h squared. The other 2 were not set on a t for us, so we had to kind of do it ourselves. But luckily we had this equation for the axis of symmetry that helped give us a shortcut. Now, on the next slide, we're going to talk about things called maximum and minimums. Now, maximum and minimums isn't something that we've talked about. It's not a concept that we've talked about necessarily in class. However, most of you, if I asked you, what's the maximum amount of people that you can have in a room? Or what's the minimum age that you have to be able to drive? You could probably express that to me. Maximum is the biggest number, while minimum is the smallest. Now, what it's referring to here on a parabola is what's the biggest or what's the smallest point on our parabolas. Well, if you flash back to our original problem, the one that was nice and cookie cutter for us, we had this graph right here. Now, it's asking for, does it have a maximum or a minimum part of the graph. Now, it's opening down. And since it's opening down, this graph is going to go technically on forever all the way down to negative infinity and all the way down to negative infinity. And it's never going to stop. So it's not going to have a minimum value because technically negative infinity is the minimum value, but we won't talk about that. If a parabola is opening down, we notice that there is going to be a highest point on the graph. Now, we know that this point on this graph is negative 4, 6. Now, we had negative 4, 6 was an important point earlier on a couple of slides ago, and you realize that negative 4, 6 was the vertex. So on a parabola that is opening down, the maximum point or the highest point will double as the vertex. The maximum point will double as the vertex. So if I'm asked what is the maximum on the graph, number 6, f of x equals 6 minus 1/2 x plus 4 squared, it's going to say there is a maximum that exists, and that maximum is negative 4, 6. So the maximum also doubles as the vertex. Looking back at the x squared plus 4x plus 1, let's look at that graph. That graph was one that went up. The orientation was up. Therefore, it's not going to have a maximum because the highest point that it reaches is technically positive infinity. So that's an easy answer. It's not asking for that then, but it's a parabola that opens up. Therefore, the vertex serves as the lowest point, aka the minimum point. This minimum serves as the vertex as well. So on this slide, when it's asking for what is the minimum of this graph, well, it's going to say the minimum is the point that was at the vertex. That vertex was negative 2, negative 3. Saves us some trouble. Instead of doing the completing the square, I already know what the vertex is based on that axis of symmetry equation. X equals opposite of b over 2a. The final graph that we talked about, well, if I just look at the equation, do you think you could guess whether it's going to have a maximum or a minimum? Remember, the orientation, the a value, tells me whether something is going to go up or down. And if you remember, if a is positive, it's going to go up. If a is negative, it's going to go down. Now, don't be confused on this one. That a value is not the 6. Even though it comes first, remember, a is always the number that precedes x squared. Since x squared is negative, it's going to open down, so therefore it's going to have a maximum value. It's going to have a maximum value. And just to refresh our memories, that maximum value was negative 3, 15, which also served as the parabola's vertex. So far we've talked about how to graph something when it's not in that cookie cutter equation that we talked about in 7.5. And we're also going to learn about maximum and minimum problems. One final topic that we're going to talk about in 7.6. Bear with me, we're almost done. 7.6. Okay, we're going to have to graph. We're going to have to state the domain, range, and zeros of the graph. Whoa, 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 whoa. These are old terms. I know it's been a long time, but let's just review. Remember, the domain deals with the x values. What possible x values are allowed in the graph? If the domain is the x values, then the range is the y values. The y values tell me where I can go up or down on the graph. Now the zeros, if you remember, way back when we were solving quadratic equations, we talked about how the zeros are the roots, the solutions, the answers, and also the x-intercepts. The x-intercepts, where it crosses the x-axis. And in 7.5, we briefly talked about x-intercepts. And the key point of x-intercepts is when is the y value equal to 0? So it just becomes a quadratic equation that we need to solve, whether we can use the quadratic formula, factoring, or whatever. So let's look at this problem number 30. F of x equals 2x squared plus 8x plus 5. So I'm going to give you a hint. These are all parabolas that either open up or they open down. All of them will be. Now, looking at these graphs, is there going to be any limit to what the x value can be? Remember, these parabolas go on forever and ever 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 forever. And they go to the left forever and ever and ever and ever and ever and ever and ever. So there's no limit to how far left and how far right the parabola can go. Therefore, there's no limit on the domain. I know this is going to be a shortcut that you're all going to be tempted to do, but if a parabola opens either up or opens down, the domain will always be all real numbers. I know you're excited. It's an easy shortcut, but the domain, when a parabola opens up or down, the domain is always all real numbers. Now, the range is going to be a little bit trickier. Now, in the previous slide, we talked about things called maximum and minimums. Maximums and minimums are talking about the vertex. Whether something opens up, it's going to have a minimum. Whether something opens down, it's going to have a maximum. That's going to determine our range. Well, if you remember, how do we find the vertex again? We have to use the axis of symmetry equation, opposite of b over 2a. So it's the opposite of b over 2a. In this problem, it's negative 8 over 4, which is negative 2. Now I need to plug this negative 2, since that's the x value. I have to find the y value. So I have 2 times negative 2 squared plus 8, parentheses, negative 2 plus 5. Using some quick arithmetic, I get 8 minus 16 plus 5. I get negative 3. Negative 2, comma, negative 3. So I have my vertex. Now, if I'm looking for my range value, because this parabola opens up, because the a is positive, that means it's going to have a minimum value. Now, on the range, it's only dealing with the y values. Well, if it's opening up, the smallest y value that it has to be is at that vertex. And what's that y value at that vertex? Negative 3. So the range values are all values, all real numbers, greater than or equal to negative 3. Now, it's also asking for the zeros. It's asking for the x-intercepts. Well, that just takes some quick use of quadratic formula. I need to figure out, when is the y value going to be 0? When is it going to cross the x-axis? And when it crosses the x-axis, the y value is 0. So let's check it out. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Sorry, cheated. It's okay, you'll get over it. So we get negative 8 plus or minus the square root of 64. Negative 8 times 5 is negative 40 all over 4. So x equals negative 8 plus or minus the square root of 24 over 4. Now if we would have looked at the discriminant, shout out to 7.3, 64 minus 40. 64 minus 40 would be the discriminant. So 24 is the discriminant. And if our sharp minds remembered, that means since the discriminant is positive, I'm going to have 2 real answers. But since 24 is not a perfect square, I'm going to have 2 irrational answers. And here they are. Let's simplify that a little bit, though. We'll divide every number by 2. We get negative 4 plus or minus the square root of 6 all over 2. And there are our 2 x-intercepts. Now, x-intercepts are points. They are not numbers. Therefore, we need 2 values. Now, since it's a point, we need an x value and a y value. Well, we already know what the y value is. Since it's an x-intercept, it has no height, therefore the y value is 0. So that's the easy one. But here's the other one. There are two answers here. One's a -4 plus rad 6 over 2, and the other one is -4 minus rad 6 all over 2. You just found the domain, the range, and you found the zeros, or the x-intercepts. Beautiful. We got one more example, and this one's even easier, I promise. So this one, let's look at this really fast. Since it's a parabola that opens up, the domain is all real numbers. The range, well, we have to find the vertex first, but luckily we have this cookie cutter equation for us. So the vertex is 5, comma, -8. So therefore, the smallest the y value can be is -8. So y is greater than or equal to -8. Now we just have to find the roots. Well, this one's going to be a little bit trickier than it was before. So 0 equals 2 parentheses x minus 5 squared minus 8. Now, I could do the quadratic formula. I could. However, notice this x value is eventually being squared, which means I can solve this using square rooting. If you notice, I can add 8. I get 8 equals 2 parentheses x minus 5 squared. Before I start square rooting, make sure you divide by 2 first. 4 equals x minus 5 squared. Square root. How many answers should I have? That's right. Make sure you have 2 answers. Plus or minus 2 equals x minus 5. So x is going to end up equaling 7 and 3. But remember, the x-intercepts are points. Therefore, we need an x value and a y value. Well, what's the y value going to be? Since it's an x-intercept, it crosses the x-axis. Therefore, the y value is 0. And the x values, 7 and 3. We just found the domain, the range, and the zeros, or x-intercepts. That's pretty much all you need to know for 7-6. If you let me know, please let me know in class if you have any questions. I'll be happy to help you. Hope you have a great day.